Hey guys, I've been working on this video for a while because it's very hard to make a video on Golang and Kafka. Because if someone who doesn't really understand Kafka or why it's really used ends up watching this video, they'll end up getting completely confused a few minutes into the video. So this means that before I can show you how to work with Kafka in Golang, I first need to explain what Kafka really does and why it's used. So in this video, I'll try to cover Kafka in as much detail as possible, and then we will look at the best ways to work with Kafka in Golang. So if you already know Kafka really well, I would still recommend you to watch the first few minutes of this video because you'll get a solid recap of how Kafka works. Now just to tell you that this video is part of the 53 Golang project series, which will become 54 now since I'll add this video in it. And the idea here is to learn Golang by building stuff. So I've created 54 projects for you. These are real world projects. You can build and learn Golang by building stuff. They're arranged in the increasing level of difficulty. So make sure you build as many as possible and share this with your friends because all of this content is free. And don't forget to subscribe because I'm always building awesome stuff. So now back to the video. Now, I've been teaching Kafka and event-driven architecture for a long time, and I wanted this video to be the best on the internet for this. And I know that the best way to explain anything is with stories, so I'm going to attempt to explain everything with a story. So it's 2024, you're a software engineer, and you get a new idea for a new web app, like all software engineers always do. You know that everyone and their mom is building something in AI, so you decide to build an AI-driven application, and you end up building a nice software for this. You start with building a monolith, and much to your surprise, this actually takes off, and a lot of people start using it. But you soon end up realizing that a small issue anywhere in the application leads to the entire application going down. But you forget about it because you get a little bit of revenue and you decide to start your own company, and two more developers who were your colleagues earlier end up joining you. And you all work on the same product together. You then realize that there's not enough separation of concern between different team members. For example, if one developer wanted to update and fix only one part of the software, he's actually having to download the entire software onto his local machine, understand the entire software, and then make changes. The software is also very tightly coupled, means you can't just change things in one module without affecting other modules. So you end up breaking the monolith into microservices. By the way, there's a lot more details on different architectures you can follow, and the actual mechanics of how this works is there in my series, the Tech Architect course. Don't forget to check that out. So after you have set up your microservices architecture, you now need to think about how the microservices really share information. When you start out, you usually don't end up realizing how much data needs to be actually shared between the microservices. So you end up calling APIs of one microservice with another. This works for some time. You scale to a few thousand users and have 5 to 6 microservices, and life's good. But soon things start breaking apart because you just cannot have that many API calls between your microservices. But you don't know that, and to fix it, you end up adding more developers to your team. But surprise, surprise, this doesn't help. So you come up with the genius idea. Why not make the front end smarter and keep the back end dumb? And make the front end call each microservice and get the required data and combine everything in the front end. This again works for a while until the number of microservices increase to about 10 to 12. And then you start seeing a lot of latency in the front end servers. And they start loading slower. And you notice that while you're putting a lot of load on your front end servers, the world is actually moving to server side rendering. And you wonder, how are they even doing it? So you talk to the engineers at some established startups, and you come to know that they're actually relying on scalable ways to ensure communication between their microservices. Something called as an event-driven mechanism, which enables your microservices to respond to events in real time. So now you want to understand what events are, what event-driven really means, and how is this a scalable approach. An event records the fact that something happened in the world or in your business. An event has a key, value, timestamp, and optional metadata headers. Here's an example event. Event key is Alice. Event value is made a payment of $200. Event timestamp is June 25, 2020 at 2:06 p.m. Now this gives you a lot of freedom because now one microservice can create an event and another can consume it. The consuming microservice will ideally trigger a response to this event and perform some operation. And this is a completely different way of working between microservices. Let's go through an example of an e-commerce product. Let's say you have 3 microservices, a user's microservice that has all the data for all the users, another microservice which will have all the data of the products on the e-commerce platform, and an orders microservice with the data of all the orders placed by the users on this platform. Each order will have a list of products ordered by the user. Now the orders microservice obviously needs the data of the user and the products that he's purchased. And with the old approach, for the orders microservice to be able to access the user's information and the product's information, it would have to call the users as well as the products microservices every single time. And this would increase the calls between the microservices. But with event-driven architecture, there will be events flowing through something called as a stream, and the microservices would be publishing and subscribing to the events, and the platform can work in a completely different way. You can have events created for when a new user signs up, to when a user is browsing specific products, to when a user adds products to a cart, and all of these can be used to trigger different actions in any other microservice. With the event-driven way, since we have more freedom, we can change our architecture a bit. Let's say that we now have a cart microservice which holds user IDs and product IDs temporarily. This is being read by a new service called the payments microservice. Then the payments microservice emits events as soon as a payment is made by a user with the particular products, the details of which we got from an event sent by the cart microservice before the payment was made. Then this new event with the user's ID, the product details, and the payment details are pushed by the payments microservice to the stream, where it is then read by the invoice microservice, where it triggers an action to generate an invoice for the user. Now the invoice microservice publishes a new event object to the stream with the user's details and the product details with the invoice ID, and this goes to the orders microservice. This approach flows better, is more organized, and you can easily add more microservices without any issues. You simply have to define the events it'll publish or consume and the actions that will take place based on those events. An important thing to note here is that all of this is happening asynchronously, which means that the producer of the event doesn't have to wait for the consumer to consume the event. The producer's responsibility is just to produce the event, and it can then forget about the thing and consumer can consume when it's ready. So now we know what events are, what's an event-driven architecture, we have seen how events flow through a stream, and how all of this happens asynchronously. Now that you know all the jargon, it'll be quite simple for us to learn about Kafka. Kafka is basically the stream where all the events will flow. On Kafka, microservices can publish events, microservices can subscribe to events, Kafka can store events for later retrieval, Kafka can replay events later in the event of a failure, Kafka can transform or process events. Publishers can sometimes be called as producers, and consumers can sometimes be also called as subscribers. So these are interchangeable terms. Events are organized and durably stored in topics. Topic, as the name suggests, has events of a particular topic. An example topic name would be payments, where all events related to payments will be stored. Topics in Kafka are always multi-producer and multi-subscriber. A topic can have 0, 1 or many producers that write events to it, as well as 0, 1 or many consumers that subscribe to these events. Events in a topic can be read as often as needed. Unlike traditional messaging systems, events are not deleted after consumption. Instead, you define for how long Kafka should retain your events through a per topic configuration setting, after which all events will be discarded. Kafka's performance is effectively constant with respect to data size, so storing data for a long time is perfectly fine. When you run Kafka, it usually runs in a cluster, and each cluster consists of multiple brokers. A broker basically is a server, and we have multiple brokers in Kafka because Kafka is highly fault tolerant, meaning it's difficult for it to go down, and having multiple brokers ensures high uptime, since even if one fails, there are always others, and this is essentially how distributed systems work. So if you've heard of Apache Cassandra, that works like this too. Every broker in the cluster has metadata about all the other brokers and will help the client connect to them as well. Client in this case would be our microservice, which would need to connect to Kafka. Now, since you have multiple brokers and some of them might go down and new brokers might join the network, so the next important thing you want to know about is the Kafka Zookeeper. The Kafka cluster is managed and coordinated by Kafka brokers using Zookeeper. When a Kafka cluster changes, Zookeeper notifies all nodes. For instance, when a new broker enters the cluster or a broker fails, Zookeeper notifies the cluster. Moreover, Zookeeper facilitates leadership elections among broker and topic partition pairings. It also aids in determining which broker will serve as the lead for each partition and which brokers have identical copies of the data. To help Kafka scale, we use partitions. Topics are separated into partitions inside the Kafka cluster, and the partitions are replicated among brokers. A topic can be read in parallel by many consumers from each partition. Producers may also attach a key to a message which directs all messages with an identical key to that division. Messages carrying keys are round-robin transferred to partitions, but messages sans keys are progressively added and stored inside partitions. Using keys, you may enforce the processing order of communications in Kafka that contain the same key. Now that we know quite a bit about Kafka, we can now start with our Golang Kafka project. We're going to create a producer and a consumer with Kafka. We will begin by creating an API using Fiber and exposing it by starting a server so that we can simply call the API, and this will produce an event from our producer. And then our consumer will also be a server which will also be able to consume the event. So creating an API makes it simpler for us to test out and produce and consume these events. Now, before we move on to the visual planning for the project, just want to tell you about my 6 AI Golang projects advanced course. It's 26 hours of killer content where I share detailed planning exercises for each of the 6 projects. And we build real-world production quality stuff like a Terraform assistant, a Kubernetes copilot, a terminal AI assistant, and much more. So if you're looking to get a great job in 2024, the main skill you would need to have is to be able to build AI-powered software. And there's no resource like this on the internet. The link for this course will be in the description of this video. Make sure you check it out. Now, this is what we're building. We're building a producer with Golang Kafka and a consumer. So let me take you through what we're doing with the producer. We're using Fiber to start off a server on port 3000, creating an API group called /API/v1. And the route will be /comments, which will be called with the help of the post method, which hits a function called createComment, which uses the comment struct that we'll create. This will define what a comment looks like. And this function is going to initialize this comment struct, is going to parse the request body. So we'll send some request body into the comments that we post. So it'll parse the request body into the comment struct. And then we'll convert the comment into bytes and send it to Kafka. And we'll do that with the help of this function called pushCommentToQueue, which literally does what it says. It pushes the comments onto the queue. And we define the broker's URL because we know that there are multiple brokers. So we define which broker to use. We create a producer message, and then we call the producer.send message, which sends the producer the message on the behalf of the producer. I call the ConnectConsumer function as well in this, which creates a new sync producer for us. So this is the flow we'll follow for the producer. And for the consumer, what we're going to do is we will set the topic, and we'll call this function called ConnectConsumer, which calls sarama.newConfig and sarama.newConsumer. I'll talk about Sarama in just 1 second. And then we consume the partition. We talked about partition already. So we'll be able to consume the errors and consume the messages. And then we'll create a channel to consume those messages and to also look for events if somebody's trying to stop like a termination message. Right? So this is what we're doing in the consumer. This is what we are doing at the producer side. So Sarama that I just showed you is a Go client library for Apache Kafka. So we'll run Apache Kafka in our Docker containers, and then we'll be able to connect with Kafka inside our Golang servers with the help of Sarama. That's why we're using it. And it's widely used, very easy to use, and you don't need a lot of hard work to use it. And it's very simple to use also. So this is the reason why we're using it. It's also very stable, and you can work with it in production also. And like I said, it's very, very widely used. So let's get started. So I'm going to create a new directory called Go Kafka YT, and I'll cd into it. And I will run the go mod init command to create a mod file for me. And I will open this up in my VS Code. So I have the go mod file here with me. And I'm going to create 2 folders. One is the producer, the other is the worker or the consumer. And in the producer folder, what I'm going to do is I'm going to create a file called producer.go, and in the worker, we'll create a file called worker.go. Now I'm building this project on my WSL Ubuntu, which is running on Windows, and I'll be running the project on my VirtualBox. The reason is that we'll require Docker to start a Kafka instance. And with WSL, things can go wrong many times when you're running a big Docker container like the one that's required for Kafka. And I've had multiple instances where the WSL has completely crashed. So what I'll do is I'll build the project here, I'll test it out, I'll fix all the Golang related issues, and then I'll import everything into my VirtualBox, and then which is also running an Ubuntu instance. That's where I'll run the Kafka and Docker, and then I'll run the project there. Okay. So, and I suggest you do the same if you're using WSL. Kafka can lead to problems. Now, I will first start with package main and import, and I'll import a few things that I need, but not yet. So the first thing that I want to do is I want to create the comment struct. So I'm going to say comment struct. And the comment is just going to have text, which is of type string, and is going to be form text JSON text. So the name of the field is text, and form also when I'll send it, and in JSON also it'll be text. Okay. Now I'll create my main function where I'll create my new server or new application with the help of Fiber. I'm using the Fiber library. I've already created a lot of projects around Fiber on my channel. In case you haven't seen it, I highly recommend you do check it out. I created the API group, and we're just following the script right now. We're just going through the diagrams that I showed you. So here I'm going to have an API called comments, and that's going to call a function called create comment. And I'm going to start off my server on port 3000. Awesome. And the first thing that I'm going to do is I'm going to create this function called create comment. So I'm going to say func create comment function takes in the Fiber context and returns the error. So I first initialize a new instance of the comment struct, and I get that in this variable called cmt. I use body parser, and I'll print out any error here. And the message will be error, and return the error. All right, so I'm going to get the body from, so as you know, if you've used Fiber before, you know that the body that you've sent to the API, the request body, will be available through the context, which is C now, because C is the Fiber context. And we convert that into the comment struct. So it's going to convert whatever body that I'm sending into the format of the comment struct that I've defined before out here. And then I'm going to use JSON, the JSON package, to marshal the CMT that I just created into CMT in bytes. I need the comment to be in bytes so that I can send it to Kafka. To send it to Kafka, I'm going to use this function called push comment to queue. I'm going to create this function in a while. And what I'm going to send here is the comment in bytes. Then I'm going to say c.json fiber.map This is when everything goes right. I'm going to say success is true, that means it happened. And after comment has been pushed, I'll say comment pushed successfully. And the comment is going to be CMT, comma. And yeah, and then I can handle the error. Error is equal to, and here we'll check for the error. If error is not equal to nil, c.status. So if there is an error, I want to return a 500 here. And then with Fiverr, I'll just have to define what that message is going to look like. Now this, I'm not creating a production level application here, as you can see. It's a small test application that I'm showing you how to work with Kafka and Golang. If I was creating a production level application, I would have much better error handling. Right now it's just a little scrappy. I'm just creating these JSON messages for Fiverr. But it gets the job done. And return error. Okay, so now this is it. This is all that our producer.go file is supposed to do from a create comment perspective. But obviously, as you know, we are calling some functions like push comment to queue, which we'll have to now create. So what I'll do now is I'll go ahead and create this function called push comment to queue. So function push comment to queue, topic, and the message, which will be in the format of bytes. And the first thing you'll need is the broker's URL. So I'm going to hard code it here, but you can have an env file if you wanted to, 290.92. And these will be curly braces, not a bracket. And I might make a lot of typos and mistakes while coding, so don't worry, because I will run this code at the end and I'll fix everything. This is how I usually work. I start with, I work like a painter. You know, you start with broad strokes in the beginning. If you've seen any Bob Ross videos, you probably know what I'm talking about. You start with broad strokes, and then you pick up the thin brush, and you make all the details, right? So that's how we build it out here as well. Okay, so I will need this function called connect producer, and all that the function does actually doesn't do much. It just helps me to connect with the producer. So I'm just gonna go ahead and create that function. It takes in the broker's URL and takes in Sarama, the library that I showed you. It's actually by IBM, I think. Producer, error. And then I'm going to say config is equal to sarama.new config, and config.producer.return.successes equal to true, and config.producer.required acknowledgements is equal to sarama.wait for all to resolve. And then config.producer. I'm just setting up all the values, like how many times do I want it to retry and what kind of acknowledgements I require, all of those things. Then I'm going to use sarama.new sync producer. That's the function that's available to me in the Sarama library, and I just have to pass it the broker's URL and the config that I just created out here with all these values which need to be set, and then I'll just handle this error that I might have here. So if error is not equal to nil, we want to return nil, error, and return connection, null. Now coming back to the push comment to queue function. So I've created my connect producer here, and then here also I'll just handle the error. If error is not equal to nil, I return the error, and finally going to close the producer. So close at the end of this function. going to create my message. So the way the message looks like is it's going to have sarama.producer message. So here you'll get this function, right, from Sarama library. That's the one we want. Producer message has topic and it has a value. So sarama.string encoder message. And then now that I've created the message, I just want to send that message. So that's also available to me in producer. So I'm going to say producer.send message. And I'll send the message that I just crafted out here. And I'll get back partition offset, or I might get back an error. And I'll handle the error now. So error is not equal to nil. I'm going to say return error. And I'm going to print out fmt.printf. Message is stored in topic %s / partition %d. I'm just going to print out the address of the message stored, offset %d /n, and I'm going to replace these with the values of the topic, of the partition, and of the offset. And finally, return nil. Right, so I'll quickly go through it again just to be sure, just so that we're also on the same page. We create a struct called comment, which has a value called text, which is string. In the form, it looks like this, and in JSON, it'll look like this, like the name of the field is text. Sometimes it might be T with a capital T in JSON, while in the form, it'll be something else. So just clarifying that it's going to be text in both the places. This is my main function where everything starts from. I create a new app from fiber.new. This is the function that helps me create a new app. Almost like Express.js, if you work with Express.js, express.new, and you get that in app. Then I've created an API group, created an API which works with the post method. The route is /comments, and I call the function create comment here. And the server is running on port 3000. Now, I call the function create comment, which then calls the function push comment to queue, and then which then calls the function connect producer, because to push comment to queue, you obviously need the producer connection. So let's go through it again. So create comment takes in the context fiber, returns an error, creates a new, initializes a new comment struct, and then whatever body it's getting from the request is going to convert that into the comment, and then get it into bytes, which I will then need to call my push comment to queue function. So I'll pass the bytes there. And then if everything happened perfectly fine, then I'm just going to return this nice message, which is comment pushed successfully. If there was an error, then I'm going to say error creating the product. Okay. And just returning the errors. Now, because we had called this function push comment to queue, let's check that what that looks like. It's going to take in the topic and the message. And I'm going to create the broker's URL, and then I'm going to call a function connect producer to help me connect to the broker's URL, which is localhost 290.2. If there was an error while calling this function, I will return an error. I will close off the producer or the connection to the producer at the end of this function. I will craft a nice little message based on the Sarama message format, which requires the topic and the value. And I'm going to then send that message. So the way to send that message is using the producer, because that is what has the connection to the broker. So I use the producer and call the send message function, and I send the message, which I just crafted here. I get back partition offset, which are the values that I want to print out to the terminal, saying that, hey, topic partition offset, this is where the message was stored. So return nil from here, return error from here if there was an error, while calling the send message function. Now the connect producer function just takes in the broker URL and returns sarama.sync producer or an error. And I'm going to create a new config, and then going to set a couple of values for the config to work properly. Then going to create a connection with the help of new sync producer function, which is available to me in Sarama. I'm going to pass the broker's URL and the config that I just created here with all the values. If there was an error, I'm going to return the error, otherwise I'll return the connection that I just created, which is getting used here. As you can see, the connection getting used here in producer. And that's how we did everything with the producer, okay? So that was it in a nutshell. Now let's go to our worker.go file. In the worker.go file, we have package main. Again, this belongs to the same package. I'm going to import a couple of things, and here I'll have my func main. So important thing to remember is that we'll be running these two files on two different servers. So you don't need to worry about them clashing because them belonging to the same package and not being in the same folder. So you don't have to worry about that. They'll be working on two different servers. So here I'm gonna say that my topic is comments, which is where everything will be there. And just like I had the connect producer function, I'm gonna have the connect consumer function here. And I'm going to pass in localhost 29092 because that's where my broker is, and worker is what I get back. Just like when I called the connect producer function here, I got back the producer. Just similarly, I'm gonna call the connect consumer function here, and I get back the worker or the consumer, okay? And we might face an error here, so I'm gonna return the error also. And then I'm going to call the worker dot consume partition. So I'm going to pass in the topic, comma 0, comma Sarama dot offset role list. So I have to pass in the topic and the partition and the offset, all of these values, so that I know where the message is. So I'll be able to consume the message properly. And I might face an error here, so I'm going to just copy and paste this, actually the same thing again. And then I'm going to print out that the consumer has started, so I'm going to say fmt.println. Say consumer started. Then I'm going to I'm just going to write some code that we usually write to create a channel. Because I want to listen to termination messages, so I'm going to say signal.notify. This is for a graceful shutdown, as you know. Sigin, comma syscall.sigin, comma syscall.sigterm listening for termination messages. And I'm going to start with the message count being equal to 0 first. These are the messages that I want to consume from the queue or from the stream. That's why I'm just going to start with 0. Create a done channel where I'm going to notify that, hey, I'm done consuming from the stream. So that's why I'm going to advertise here on the done channel when I'm done consuming. And I'm going to start a go routine, which will help me do some tasks simultaneously. So I'm going to run through a for loop, select, and case. If there's an error, we're going to print out those errors. And if there is a message, we're gonna consume that message. So you can say consumer.messages. The way to consume that message is to begin with, we'll increment our message counter that I've created here. It was 0 in the beginning. The number of messages we consume, we have to keep incrementing the message count so that we know how many messages we have consumed. And I'm going to say received message like message 1, message 2, message 3, right? We want to print out to the terminal. So I'm going to say, I'm going to print out the number of messages I've received and the topic that it was on. So I'm going to print out the topic as well. Then the message itself, /n. And here I'm going to replace these things with the message count, which are the actual values, which will be replaced here, and the topic and the message. So the message count. Then I'm going to get the message dot topic, and finally the messages value, message dot value. All right. And if there is an interruption or the termination message that I'm expecting, then I'm going to have a graceful shut. I'm going to say interruption detected. And finally, I'm going to advertise on the done channel that, hey, I'm done consuming the messages on the stream. And out here is where something seems to be wrong, because I don't think I have closed the right number of brackets. I don't think it should be there, actually. And I think something seems to be wrong, because I have the bracket for the bracket for select, yeah, and the bracket for the go routine. Now this looks okay. And I'm going to call the go routine, and then the main function, I just closed it with this bracket. Okay. So now everything looks all right. Then I'm going to just say done channel, and I'm going to print out the message count and the messages. And we close the worker. And print out and panic with the error. So this was our main function, and now I just need to create this function, which was connect consumer function. So let's do that. Let's create that good function quickly. So connect consumer broker's URL takes in the string and Sarama dot consumer error. And here, first things first, I'm going to start with the config, just like I did in the create producer function. Creation of a config, and then setting some config values, so consumer dot return dot errors equal to true. And then I'm going to use Sarama to create a new consumer, which is going to have the broker's URL and the config. I'm going to get back the connection to the consumer or an error. I might get an error back. And what I'm going to do is I'm going to print the error. And I'm going to return connection nil. All right, so this is your worker, and that was your producer. The spelling of producer is wrong out here, and I'm sure there are like countless mistakes in the code. I'm quickly going to, oh, it's by Shopify. So Sarama is by Shopify, but I remember seeing IBM somewhere, so I think IBM also has something to do with Sarama, not sure. But anyways, in the producer, I'm going to import Fiber. Somehow I didn't end up importing Fiber. I need Fiber. And I'm going to go ahead and run go mod tidy. That's the first thing I'm going to go ahead and run, go mod tidy. Okay. Yeah, see, something is wrong, right? It says IBM Sarama or Shopify Sarama. What's the scene here, man? Was it like, it used to be Shopify just like a few days back? Because when I created this project and now suddenly it's IBM. Is it like that? I'm not sure. Let me check it out. Sarama. Kafka. Sarama. Kafka. Yeah, it is with IBM now, that's for sure. I'm not sure if you can see my screen. It says IBM Sarama. That's weird because just a while back it was Shopify. Anyways, so now what we'll have to do is we'll have to change the path like it's saying, like it's telling me to, which is IBM Sarama is what I'm going to have to change it with. IBM. Okay. And here also I'm going to say IBM, right? All right, so I'm going to go ahead and run go mod tidy again. And now it's getting all the dependencies for me. And now I can still see some errors are there. So that's what we are here for. We have to solve all these errors. So we're going to say cd producer go and go run producer.go. Let's see what kind of issues. Okay, so it says line 74, line 75, there are some issues. No problem. We can check that out. Line 74, sorry, producer line 74 is comment. Okay, right. Okay, this is the create comment function. I have line 74 success message and comment. Oh yeah, there should have been a comma out here. Should I try running it again? Yeah, I think this is running now. Shouldn't be a problem anymore. And I'm going to now fix the, sorry, go run worker.go. Let's see if there are any Golang issues. There are on line 43 and 46. So I'm going to go ahead and put line 43 and 46. Okay. What's happening on line 43? Yeah, this shouldn't be like this, right? Line 43 and 46. Okay. So this I'll fix, but what's there on line 46? That's what has me confused. This is usually, sorry, this is fixable. What's there on line 46? Seems to be all right. Is it because there was an issue here and that's because of that there's an issue on line 46? Is it because of that, or not sure? I'm just gonna go ahead and run it anyways. So okay, line on 26 and 35 also there are some issues. Line 26. Okay, what's the issue here? Oh yeah, 6 channel. So it's called .sigint. So it's called sigterm signal.modify. 26 feels okay now. 35, it said 35, right? 35 consumer.error. What's the issue there? Oh, it should be consumer.errors multiple. Let's run it again. Okay, yeah, that's perfectly fine because we don't have Kafka running there, so no problem. So at least it told me this, but I didn't get anything back from the producer, and that has me concerned. Producer.go. It doesn't say anything, right? Which I think should be okay. I think it should be okay. But let's go ahead and test it out in my inside my VirtualBox, and let's see what happens. So here, as you can see, I'm in my virtual box now. I've opened up the terminal. I have run the sudo docker compose up -d command. So the thing is, the code for this project I've already put now on GitHub, and you'll be able to run docker compose up -d is what you have to run in the root directory. And this will start your Apache Kafka and Zookeeper. Okay, so I've done that. And I just have to run the producer.go and consumer.go now. And then this is the Go Kafka example in Akhil Sharma 90. That's the name of my account. Anyways, so now what we'll do is we will go ahead and run. Here I've opened up the producer. So I'm going to say go run producer.go. And here I'm going to say go run worker.go. And here I have my terminal open, where I'm going to go ahead and put in the curl commands that will call the API. So I just realized I can't copy between my WSL and my VirtualBox. So I'm going to go ahead and have to open up the browser here and get access to the APIs. So I have opened up in my browser here the project, and now I can just copy the curl commands. I was too bored or lazy to type everything on my own again, the whole curl command, but I've already put it in GitHub, why not? So here I get the reply back saying command pushed successfully, and your producer is running, and your consumer just received one message. So the count is 1, topic is comments, and the message that you received is message 1, which is what you sent. You sent message 1, right? Now let's send the message 2 and see if it still works. So copy message 2, and here I'm just going to press enter a couple of times. And here I'm going to call my /API/v1, which is my group. Comments is my API. Port 3000 is where the project is running. Post is the method. And I'm going to send text message 2 and data raw. Text, if you remember, that's what the comment is looking for. And when I press enter, I'm going to get comment push successfully, success true, text message 2. And I get here received message count 2, topics comments, and message 2 received successfully. So I hope you enjoyed building the project along with me. And like I said, this is on GitHub. Make sure you check it out. Check out the code if you're not able to make it work. And obviously join the Discord community for this YouTube channel, because that's where we discuss issues and errors and even career advice and how to find jobs. So we talk about all that kind of stuff. So make sure you join it. The link for that also will be in the in my profile on YouTube. And the link for the course that I talked about earlier, which was the 6 AI Golang projects course, is also there on my profile and also in the description of this video. Now, the other thing is I have on my channel the playlists for Rust, for AI, for technical architecture, and for system design. Make sure you check those out also, and don't forget to subscribe. Thank you so much for watching, and I'll see you in the next video.